In this first video for Chapter 9, we're just going to introduce the idea of a test of significance or a hypothesis test. First, let's contrast a confidence interval and a hypothesis test. A confidence interval uses a sample statistic to estimate a population parameter, but a test of significance, also called a hypothesis test, a sample statistic is used to test a claim against a population parameter. So, for example, in the intro activity called I'm a Great Free Throw Shooter on page 538, a player claims to be an 80% free throw shooter. I can shoot 80%. Or I should say I can make. The player can make 80% of her shots, 80% of her free throws. So that's her claim. Now what are we going to do to test the claim? We're going to watch her shoot some shots. And after she shoots some shots, we're going to say, is the amount she make convince us that she's an 80% free throw shooter, or does it make us think she's exaggerating? Okay? So we're going to go to an applet here that allows us to test this, to shoot a group of shots. So let's start with just shooting 10 shots. So this simulates shooting 10 shots, and it plots so far she's made them all. Oh my gosh. Well, looking at that, I'm thinking, wow, she might even be a 90% shooter. Or maybe she just happened to have a really hot streak, so I'm going to have her shoot another 10. Well, you know, I'm kind of inclined to believe her. In fact, she might even be a better than 80% free throw shooter. So now it's going down a little bit more. So I'm going to say, based on these 30 shots I'm seeing, she's hit 83% of them. I'm going to say, yeah, she's right. So I'm going to say, show the true probability. Yep, she is an 80% free throw shooter, and she did convince me by the evidence. Okay. So let's pick a new shooter now. Have this shooter shoot 10 shots. Well, right now it says 70%. I'd still believe a person being 80%, but you know, who knows? Maybe it got kind of lucky. Let me see. Oh, now I'm not so, wow. This person was off to a great start, but now they've only hit 50% of their shots. Let me have them shoot a few more. Okay, I am very convinced at this point that this person is not an 80% free throw shooter. I'd believe maybe a 50%, maybe 60%, but definitely not an 80%. So let's show the true probability. 40%. Oh my gosh. This person's a 40% free throw shooter. They just happened to make a bunch at the beginning, got really lucky, and then started hitting their normal amount towards the end. Okay, so if I just looked at my first sample, I would have said, yeah, I think they are 80% free throw shooter, but they were really only a 40% free throw shooter. So it kind of shows you when you take a little bit larger sample, sometimes you can see better. Let me try one more. Feels like all of mine start out shooting well, and then well, based on this first sample, I would say 80%'s reasonable, but this person's pretty erratic. I think I better have him shoot some more. Well, I would say based on this, it looks more like around 70%, but it would still be plausible that they might be an 80% shooter. But let me try the true probability. Okay, 65%. Okay, this person's 65% shooter. So you can see that the evidence here is stronger the more shots they take, and also it's harder to tell. When their shooting percentage is close to 80%, it's a little harder to tell if the evidence is strong enough. If we saw a bunch of them down here that are really low, then the evidence is a little stronger that they would really not be an 80% free throw shooter. So it kind of gives you an idea of what we are looking at as we think about evidence against a claim. So let's think about a simulation. Sometimes it's hard to tell how much variability we should expect in a true 80% free throw shooter. Maybe sometimes they're going to hit 60, maybe sometimes they're going to hit 85. If they hit only 60% or maybe 65%, would that be enough evidence to say they're not 80%, or is that just maybe they're having a bad day that day and they're still really an 80% free throw shooter? So let's do a simulation here. In our simulation, let's say the claim is true. The player really is an 80% free throw shooter. How likely would it be for her to shoot 53 throws and only hit 32 out of 50, or 64%? Would that be really unusual, or could that happen maybe with an 80% free throw shooter? So we need to think about how to simulate that. And we've done simulations a lot of different ways. We could put 8 plastic, 8 poker chips in a bag, and we could have 2 of them be red and 6 of them be white, and the 2 red ones would represent, I'm sorry, we'd have 10 of them, 10 of them, and 8 of them would be red and 2 would be white, and white would represent missing a shot, and the red would represent making a shot. Or we could have a spinner with 10 sections, 2 of which say miss and 8 of which say make. Or we could use a random digit table, and we could use the digits 0 through 9, and we could say 0 and 1 represent a missed shot, and 2 through 9 represent made shots, and then we could go across and do 50 numbers and count how many were made out of the 50. We could also do that on the calculator with a random int from 0 to 9, and then we would look at 50 shots. So in the interest of time, we're going to do the calculator version because that's the fastest version. And so each student, this is what I wanted each student to do, is to first do a random seed to get so we're all in a different place in the random number generator. And then we're going to do a random int 0, 9, 10. It shoots, this does 10 shots at a time. And then we do that 5 times in a row, and that gives us 50 shots all showing on the screen at the same time. It makes it easy to count how many they missed. So 0 and run represent misses, so this would be 1, 2, 3, 4, 5 misses. So this person hit 45 out of 50 shots, or 90%. Now, we did this over and over again in the class, and we made a graph of all of our p-hats, which are sample proportions of made shots. And this is what we ended up with. We ended up with this graph here. So here's our assumption that 80% are made shots. If 80% are really made shots, what's our sample proportion? So sample proportion p-hat is the number made free throws out of 50. And we looked at lots and lots of samples, and we saw that occasionally we'd get as high as low 90s and occasionally as high as the high 60%, but the majority, vast majority of the shots were between about 70% and 90%, with 80% definitely being in the middle of our distribution. So my question here was, how likely was it that a player would hit 32 out of 50, which is 64%? And nobody actually got that result at all. So we're going to change it to, what's the likelihood that they hit 34 out of 50, or 68%? So we see here that there is one that was at 68%, and there was one that was less than 68%. So what's the likelihood that this would happen? Well, it's pretty small. So what would be so if we did happen to see someone that hit 68%, we would have 2 possible explanations. Number one, they really are an 80% shooter, but had a bad day. An unusually bad day. Usually bad day. That would be one possible explanation for that sample. The second possible explanation for the sample is she is not really an 80% shooter, because that would be so unlikely to occur if she really was. Now, could it occur? Yes. Very rarely it could occur. So there is the possibility that she just had an unusually bad day. But the other possibility is that she's not really an 80% shooter, and that's why she got such a low percentage. So this is kind of the idea that we have to think of when we think of a hypothesis test, is what is the evidence for what is the evidence against the claim, and is that evidence strong enough to really say that the claim is wrong? We'll look at more of the details then as we go into some subsequent videos.